Ah, come on.
We might have to take one down, maybe not the top.
Can I?
No.
Trent, you have your note, take it out.
Yep.
Chief?
Right here on the desk. When's any of the wood?
Multiply. Divide. And simplify. Rational expression. Okay, so when I simplify, including multiplying and dividing and everything that goes with that, when I'm dealing with rational fractions, this will be true for adding and subtracting as well. When I go to do all that, there's still one rule I need to keep in mind, and that is that I can't have an undefined fraction. So when is a fraction undefined? When the denominator is 0. So example, if I have 1 over x, guys, if that's my equation, what can x not equal?
0.
Right, so x cannot equal 0.
Does nothing can be divided by 0?
What?
Can nothing be divided by 0?
Nothing can be divided by 0. It is undefined to be divided by 0. Always.
And why is it?
What?
Why?
You can't divide something 0 times.
Right. How many times will 0, technically, how many times will 0 go into 1? An infinite amount.
Yeah, that's what I was about to say.
I don't know, I mean, but I guess, yeah, I know. A theoretical mathematician would probably say it's got to be either that or it can't go at all. It's one of those two things. So we just call it undefined. All right? So anytime you get 0 on the bottom, we're undefined. Okay? So when we go to simplify rational expressions, it's all math you've already learned before. The only thing you need to keep in mind, Trent, is that I have to state restrictions. I think you're surprised. I have to state restrictions so that I don't have an undefined function. So, how to simplify rational expressions? We're going to go by steps. First step, always, I want to factor, and I want to factor both the top and the bottom, so both the numerator and the denominator, if possible. So if I get to it and I can't factor it, or if it's already factored, then I'm not going to do that. I'll skip this step, right? I want to factor for 2 reasons, and those reasons are step 2 and step 3. So step 2, after I factor both the top and the bottom, all right, I want to state my restrictions. If these were equations, not expressions, if I told you not to simplify but to graph them, we'd be looking for vertical asymptotes, right? And I would do that by solving for what? X put on the bottom, right? The denominator specifically, because for vertical asymptotes, I don't want 0 in the denominator. So when I'm stating restrictions, I'm doing the same thing. I'll take the denominator, see what I can't have, because if I have a certain value, I'll get 0. So that's all my restrictions are. So factoring is the easiest way to do that. We'll do example problems, you'll see. All right. I also want to factor for step 3, because I want to simplify by canceling like terms. And if I can't just cancel, I want to simplify too. Those 3 steps every time. You might skip step 1 because it might already be accurate. So simplify each rational expression, show your work, state the restrictions on the domain. So what is step 1? Factor, if possible, right? Well, looking at this top part at least, that looks like it's probably going to factor, right? Bottom one will too, but we'll get to that. Let's just do the top first. I'm going to trip over this and this. And this binder that's been here for 3 weeks. Yeah, so let's factor the top. X squared minus 2x minus 15. So I need factors of negative 15 that add negative 2. All right, so 1 and 15, not going to work. 2 doesn't work. 5 and 3. If I do negative 5 and positive 3, so negative 5 and positive 3. So good. So x minus 5, x plus 3. Good. All right, how about the bottom? So the bottom, this was over what? X squared minus 9. Negative 3 and positive 3. What makes you say that, Colton?
Negative times negative is a positive.
Good. Yeah, specifically, it's a difference of squares, guys. Is x squared a perfect square? Yes. Is 9 a perfect square? No. What's the square root of 9? 3. So this is a difference of squares, and my pattern for difference of squares is x plus 3, x minus 3. So are we done with step 1?
Yes.
Awesome. What's step 2? State restrictions. So what values can't I have? Because if I plug in those values, I'll get a 0 on the bottom. Negative 3 and positive 3. So if I take each of my factors, I've got an x plus 3, I've got an x minus 3. If I set each of those equal to 0, right, I'll get x equals plus or minus 3, right? If I plug either of those in, if I plug in plus 3, that's going to be 0, meaning anything times it is 0. If I plug in negative 3, that's going to be 0, meaning anything times it is 0. Both of those will get me undefined values. So this becomes my restriction. Every time. That's why we factor the bottom. That's way easier than looking at x squared minus 9 and going, all right, does 1 work? Okay, we're good. Does 2 work? Okay, we're good. Does negative 1 work? No, way easier. Factor and solve for x, right? Good, so I've stated restrictions. I'm going to put a box around that because that's kind of good, right? So what's my last bit? Cancel like terms. Christian, what do you see that's going to cancel here? The 3? The x plus 3, right? Don't I have a x plus 3 in top and bottom? Very, very important that you state restrictions before you cancel. If I canceled and then state my restrictions, I would lose negative 3 as a restriction. Got to do these steps in order. State restriction, then cancel. So my final answer for this, I've got my restrictions, and then I need to simplify totally. X minus 5 over x minus 3. I'll put a box around that as well. Boxes. No, because they're being added and subtracted.
Oh, I see.
Right. If it was 5x and 3x, I can cancel the x's and it'll be 5 over 3. But if I'm adding or subtracting, those do not cancel. 3. Well, so for the top, let's say I did positive 5. If I do positive 5, do I get 0 in the bottom anymore? No. So I don't. That's all I care about is getting the bottom. It's just like, guys, it's just like when you look for vertical asymptotes, right? When I'm graphing, I take the bottom to find my vertical asymptotes, right? So this is the same. If we were graphing this, so these would be vertical asymptotes, but we're not. We're just simplifying. So. Cool? Oh, good. All right, can I erase it to do B? This bit? Hold on, I learned this. Ah.
You didn't know that?
No. I just learned, it doesn't work on this one, but have you seen the one where you use 2 fists? You can double fist? Yeah. Well, like, it does, like, everything in between.
Really?
It's like a window shade. It just erases it going. It's really cool, actually.
We have one up at my other school.
Hold on, Lucky's got something really relevant to say.
It is relevant.
Is it actually?
Yeah, it is.
Relevant to
All right, hold on to it. Good. B. B. All right, so what's the first step? Factor. Is 5 in a factor? No. Okay, how about x plus 5? Charlie, do you know of anything I can pull out of that factor? No, there's nothing to pull out. Good. So guys, the first step says factor blah 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 blah, if possible. So factoring's not possible here, so let's skip it. Colton, step 2. What do I need to do next? Good. So what is my restriction on this equation? Thank you, Colton.
X minus 1.
X, yeah, x cannot equal -5. Right? Good. So is there anything that cancels? No, I can't cancel 5. So if you do that, I will write you legal math on your paper and take off points. Those don't cancel, right? Those don't cancel. This is it, guys. You could rewrite it like this, or you could give me an answer that just says already simplified. If you didn't want to rewrite it, that'd be totally fine. I'm recording. Just realized I'm not copying. There we go. Good. So either way, that's a little curveball.
Like a curveball.
Look at this little phone.
Yeah.
Really?
We're good. Yes.
Always wanted to try my room. Just figure out.
So that's simplifying. Now we got to multiply and divide. Nice thing about multiplying and dividing is they're very, very, very similar. It's just one little tiny extra step we'll do for dividing. So, if you had to guess what step 1 is for multiplying rational expressions, factor. Same today.
GG.
Good. So, factor if possible. Brent, what do you think step 2 is? No. What's the other option? Thank you, Brent. State restrictions, guys. Action, what do you think step 3 is? Cancel like terms and signs. They are for these two. They are not for dividers.
Is it weird for dividing?
No. It's just slightly different.
I already think that this is kind of weird.
Okay. Yeah. Well then, yes, dividing is weird.
Stating restrictions.
Nope, that's not weird. Nope. Because dividing will be different. Okay. Perform the indicated operation. Perform the indicated operation. Show your work. State the restrictions on the domain. Same question as before, right? But look, I've got a rational expression, a fraction, times the little dot, another fraction of the rational expression.
Is there not a fourth step?
Nope. So, what is the first step, Trent? Factor if possible. All right, so let's just go. Here's how I would think about it, guys. Almost like quadrants. Let's go 1, 2, 3, and 4. So this first one, top left, 8x cubed times 1. Anything I can pull out of there in terms of factoring?
No.
Sir?
No, I mean, no. Yeah, no, I don't think so. If it was y squared, maybe I could pull something out, but no, right? All right, go down one step. How about this bottom part? 2xy squared. No. Nothing. 4y? Definitely not. 7x to the 4th y cubed.
No.
I can pull out a what? Why would I do that? Guys, if there's no plus or minus, everybody, if there's no plus or minus in any of my terms, there's nothing to pull out in terms of factors, right? So, what's step 2? State restriction. So we need to look at our x's in the bottom. Here's what's really nice. Look at this guy. He's not going to give any restrictions for x.
Okay.
but this one is. What's my restriction on 4x, y, so y squared? What can x not equal?
2. Negative 4.
Set, guys, if you're in doubt, set it equal to 0. So 2x, y squared equals 0. We want x by itself. So let's divide by 2y squared. So x equals 0 over 2y squared, which is just 0. So that's my restriction. X cannot equal 0. Okay, cool. So then step 3. Cancel like terms and simplify. Okay, this one I can do. Guys, with canceling like terms and simplifying for multiplication, you can do it all at once while they're separate terms. You could multiply everything first and then start canceling. I do kind of in between. So I'll show you the way I do this. Some people like to just keep them totally separate. So, I've got, I'm going to erase this. Oh, my shirt.
How much?
Well, my shirt made lines on it. So, okay. So, I'm going to go term by term. 8 over 2. Is that going to simplify it all? 8 over 2? Won't that become 4 over 1? Okay, let's go to the next one. X's. I've got an x cubed over x. Yeah, that'll be an x squared, right? Technically over 1, but I'm gonna erase all the 1s and not write them. 1s are just 1s, right? Good. So then y over y squared. Right, 1 over y, right? There's a 1 up top now. So I like to do that. All right, so now let's. Oh, you serious? Okay. Times. I've got a 7 over 4. Is that going to reduce? That's going to stay 7 over 4. I've got an x to the 4th over no x's, so that stays, right? Okay, and then a y to the 3rd over y. Good, y squared. So that definitely go through and do that at least, guys. Now there's a couple of steps you can do. I could multiply this together and then re-evaluate, see if anything needs to be canceled, right? Or right now, I can take my red ink. What do you see that's going to cancel? Yeah, I've got, well, hold on, I've got 4s. I heard a y as well. That'll go away. This becomes just a regular y, right? Okay, so it helps having 2 different colors. Anything else going to cancel?
Not cancel.
Not cancel. Those will multiply, right? So good. Now what's left? I've got an x squared times a 7 times an x to the 4th times y. It's all over 1. So this becomes 7 x to the 6th times y. And my restriction is x can't equal 0, right? That's from before. I erased the x can't equal 0, do some work, but that's just from before.
Was that all just A?
That's all A.
Just all the stuff.
Yeah.
So how much work do you do?
Somewhere in between what I showed. I mean, if you need, for your purposes, need to write all that out, please do, and more. But needing to show work, it's somewhere in between that, right? You don't need to show me literally every step. I don't need to see, like, I want to see, that you reduced 8 over 2. I like to write this and then this, right? And then maybe if you show me what you crossed out, you can go straight from here to here. Does that make sense? Oh my gosh, are you serious? Can you wait a while? You just got that. Let me get the notes. I know. He also said in the first email to make sure you can finish all your work.
Oh.
So,
I didn't get up like that.
I know.
No.
Nobody. Playing the rain.
Ranger.
Or not.
How you have the x not equal 0, is that just pull that down in the first part? Or is
Right, that was from here, right? That was from there. I just erased it. So cool. All right, number 2. Ready? Number 2. Let's go again. Think about it like quadrants. I got tops and I have bottoms. top left, that's just an x. Is that going to factor? No, so we'll just leave that as x over. My x minus 3 on the right is not going to factor either, right? So I'll get times an x minus 3. So my bottoms definitely look like they're going to factor. 3x squared minus 9x. Brent, what can I pull out of each of those?
3x.
3x. Good. 3x, and it leaves me with what? X minus 3. Awesome. What do you already see that's going to cancel, guys? Good. I'm going to go right now. Oh, somebody said x's. Also the x minus 3. Gigi said the x's are going to cancel. Those guys will go, right? Good. So now we'll keep working. Let's do the other side. 2x squared plus 3x minus, or sorry, 2x squared plus x minus 3. You said 3 and 2. The problem is that 2 on the front, right? AC method, I've actually got negative 6. So factors of negative 6 that add up to positive 1.
2.
Yeah, 2 and 3 work. Yeah, 2 and 3. What? Well, you did, but you didn't say that to split the terminal. So
Maybe he didn't do it.
maybe and maybe you did. Maybe you didn't. Fair enough. So minus 2x. You want to do plus 3x minus 3? Do we want to do it like that? I think that's the way to do it, because what can I pull out of those first two? I can pull out a 2x, leave me with what? X minus 1. And then I want to get an x minus 1 here, so what can I pull out of that guy? Just a positive 3, right? Leaving me with, this actually equals 2x plus 3 and x minus 1. So is anything going to cancel there? There's nothing left really to cancel. I canceled it all, didn't I? So
You wait and cancel until you get all the also.
you what?
You wait and cancel until you get all the.
Oh, until I get you should wait to cancel. Yeah. What guys? What step did I skip here? Restrictions. Good. Luckily I didn't go on and do everything. So now I'm going to stop. Even though I put red ink through things, I need to do restrictions. So I've got factors of 3x, I've got an x minus 3, I've got a 2x plus 3, and I've got an x minus 1. So these are all going to give me restrictions, right? These are all factors on the bottom. So 3x will give me what? 0. Yeah, so x can't equal 0. Yes. What?
You got it.
Well, don't write as big as me.
Right, Gar.
Alright, okay. Alright, well. Yeah. Like tattooing a grain of rice. You can do that.
That'd be awesome.
Yeah, it looks like, or like, they take pencils and then like, they sculpt the.
Alright, so it's all on the very top of it.
Yeah.
Okay. Anyways. So do you like that?
Hey.
Hold on. Alright, so restrictions. I've got a 0. What will this restrict me to? 3. So this will subtract 3 and divide by 2, so negative 3 halves, and then 1. So x cannot equal 0, 3, negative 3 halves, or 1. There's a 1. Lucky.
The very first fraction is originally a 1/3.
Very first fraction.
X over 3x, parentheses x minus 3.
X over.
Cross over the.
Yeah, this becomes, yeah, 1 over 3.
Yeah.
Yeah. Okay, we're just not there yet. I need to stay restricted.
Oh,
Good, so I've got restrictions. I went ahead and did my red ink. So now I'm going to multiply across. This whole thing on the top is what? 1, good. Over, I've got a 3. I've got a 2x plus 3. And I have an x minus 1. And guys, I would just leave your answer like that. Nothing cancels. You don't need to factor anymore. Simplified, right? Leave it just like that. copy it before I erase it, then don't leave myself enough room on there. Next note packet I'll do differently. Okay. We're doing that. Oh, darn.
We're not taking out it.
Action really wants out of here.
I have a question.
Yeah.
Kind of want to do
So,
hold on.
Here we did.
Would you, the one,
He's really good at that.
he knows how to piss me off.
All right, C. No, guys, C. Go by your different terms. Top left. Is top left going to factor at all? No. What about bottom left?
Yeah.
Well, here's the thing about bottom left, right? So if I rewrite that, I've got 4x squared on top. X plus 2 squared is actually x plus 2 times x plus 2, right? Now does it look like it'll factor at all?
Yeah.
No, that's already factored, right? That's already as simple as it can be. So we write it like that and it looks better, right? So that's times, the over 2x squared isn't going to factor, right? But x squared plus 3x plus 2, that's easy factoring. What does that break into? Somebody besides GD.
Oh, geez, one.
X squared plus 3x plus 2? 2 and 1? X plus 2, x plus 1, right?
Sorry, I can't factor.
Yeah, I gotta write it down.
Cool. Alright, so am I completely factored? What?
Yes.
Yes. Yeah, I'm totally factored, right? So step 2 is?
Stop. Where did you get that?
Where'd I get what?
X plus 1 times x plus 2.
That's x squared plus 3x plus 2. Factor. Right there?
Oh,
Is that factored?
never mind. I was,
Good?
yeah.
Good. We're finding restrictions. So, just on the bottom, guys, what restriction is that going to give me? So x can equal -2. That one gives me the same thing. I'm not worried about the fact that it gives, there's nothing I write to say twice, or anything like that. It's the same restriction, right? Cool. And then on the right here, what can I not equal? 0. Okay, step 3. Simplify. What's going to cancel? Ashton, what's going to cancel?
X plus 2.
Good, so an x plus 2 here and an x plus 2 here.
X squared.
Good, so these x squareds, so these aren't going to completely cancel, right? But what are they going to become? Yeah, that'll be a 1, and this will just become a 2. Everybody see that? 4x squared divided by 2x squared, that's just 2, right? Anything else cancel?
No.
No. Hold on, Cole. So let's write it out. I've got 2 times x plus 1 over x plus 2. That's it, right? Times 1, right? But you don't have to write it. There we go. Boom.
Why? You can cross out the x1, x plus 2, right?
I crossed out one of them, didn't I?
Because there's not another one.
But there's 3 of them.
I know, but it asks you one for each.
Alright, 1 for each. So I can't take this and say, well, there's 2 down here, so I'll just pretend like there's 2 up here. No, there's got to. This one there were 2 because it was squared.
It's got to be 2 on the top.
Right. Yeah, you can only, it's 1 to 1. So good. And then obviously offset. Watch closely. I'm gonna listen up. I'm gonna skip D. The only thing that's special about D is that a fraction? No, it doesn't look like one. Bruh. Okay, it doesn't look. Oh, I like this actually. It doesn't look like 1, but that's actually over 1, right? Cool?
Can you,
Bring that to questions.
Don't screw up.
Okay.
What was the difference between that?
Oh, all right. Very good.
Alright.
What? Oh, you mean like that?
Do we have any other questions? Yeah.
How about we do?
Oh, that.
Yeah.
Scroll down.
Hey,
So it's right there. Gotcha. Okay. Well, oh, you still working? All right, go for it. We're not doing this.
Oh,
now.
okay. Never mind.
Did you have good?
Okay. Dividing rational expressions. I can't go too much because I'm short. I can't reach up.
Oh, no, we're short.
No one cares.
No, we're short.
No, I'm actually the average height for an American male. 5'9" 3/4.
6.2.
You're back in the line.
And 3/4. That's 3/4 because I'm 4. No, ask them. Well, I want to ask you something. All right, how to divide rational expressions. Oh, this is a question about this.
Have you always?
So no. Good. Dividing rational expressions. Amelia, Lucky, Ruth, Anna. What do you think? What do you think step 1 is?
Okay, some of the questions.
Ashton, how's your day going?
Just fine.
Factor. Nope, there's only 12 steps. So it'll go quick. So, guys, step 1 is the same. Charlie, factor if possible. I'm doing shorthand. You should factor both the top and the bottom if possible, right? On all your terms. What do you think step 2 is?
Check the accounts.
State restrictions, and if you're thinking this is the same as the first two, you're wrong. You're wrong. State restrictions. Alright, for step 3, look ahead at one of our problems. I've got an x plus 3/4 divided by... Hold on. Oh, well then hold on. Divided by 4, or divided by 2x plus 6 over 3. So I've got a fraction divided by a fraction. Colton, when I'm dividing by a fraction, do you remember what that's the same as?
Why don't you give all people?
Who got his hand up?
Flip the reciprocal.
Flip. It's the
Bang,
same as...
bang, boy.
Colton, it's the same as doing what by the reciprocal? So what do I do with that reciprocal? Yeah, I flip it. Multiply. Good. So eventually, guys, when we get down here, I won't divide by 2x plus 6 over 3. I will multiply by 3 over 2x plus 6. Okay? Well, because multiplying we already know how to do. So from there, it's the same. Here's the deal. For step 4, after I'm going to say flip to reciprocal, here's where people get tripped up. Guys, after I flip it, I have to restate my restrictions.
What would that change?
No, hold on.
There's 5?
There's 5. Christian, when I flip,
Not your language.
Christian, when I flip x plus 3 over 4 divided by 2x plus 6 over 3. Guys, when I start here, am I going to have any restrictions before I flip? I don't have any x's in the denominators, right? So no restrictions. But then when I flip that to its reciprocal, 2x plus 6 over 3, when I flip that, I have a new restriction, right? Because this will become 3 over 2x plus 6, meaning x cannot equal negative 3, right? That's negative 6 over 2. We'll get there. We're going to do that problem. So if your question is about that problem, I'm going to get there. There's still one more step. No, wait. Hold on. So then step 5, after I restate my restrictions, I've already factored, I've done everything. So the final step, yeah, you'll multiply and simplify. Actually, I want to do one example problem. No. We'll work. I'll show you. So perform the indicated operation. Show your work.
Why do you have to say for start?
Just enough, but I'll show you again. Okay. Show your work. State the restrictions on the domain. So step 1, always factor, you guys. So is x plus 3 going to factor at all?
No.
No. Is 4 going to factor at all? No. Divided by 2x plus 6.
You take out 50.
Yeah, I can take out a 2 on that. Guys, that seems, listen up. Taking out a 2 seems like a small, like that's not going to actually do anything. Here's my rule about factoring. If you can factor, do it. It will help you. It seems like, well, I'll just work with that how it is. It will help you, I promise. So divided by 2, leaving me with what? X plus 3? Over 3. So on this problem, we already said this. How many restrictions do I have? None. None yet. Good. Step 2, state restrictions. Done with that. So now I need to flip. People are asking me, which one do you flip? Do you flip both? No, you flip one. How do you know which one to flip? Guys, it is always whatever you're dividing by. So dividing by, so I'm dividing by a fraction from this guy. So I take that and I flip it to a reciprocal. So that changes to x plus 3 over 4 multiplied by 3 over 2 x plus 3. So then step 4, what is it? Restate restrictions. This is why you have to restate your restrictions. Alex, you see that? Before I didn't have any restrictions, now I do. Down on these guys, I'm going to have restrictions for both of these. Then I'll flip, and my top will become a restriction. Yes. So you're not stating new restrictions, guys. I would take the old ones you got and just add to it. But you can give them, yeah, you can give them to me as one big answer, and then you can score in after. Yeah, well, no, if you didn't, you'd go, why you're doing it twice. No, I need all of them. Yeah. All right, Brent. So a restriction is any number that when you plug it in, you get 0, right, on the bottom. So here, I didn't have any x's.
How long ago?
Call me out.
Brent asked, how do we know exactly what a restriction is? When in doubt, Brent, just take all your factors on the bottom. I'm only worried about the bottom, right? And set them equal to 0, and that'll tell you where they are, right? So solve for x, and we'll do a couple more, right? Good. So, Brent, what cancels here? Because that's step 5, right? Multiply and simplify. Yeah, both these x plus 3s. I didn't write the restriction. Thinking. Right. What can x not? X cannot equal -3. Not 0. Where'd you get 0 from? The 2? You want to set 2 equal to 0? Yeah, if there was an x there, Gigi, you'd be right. So if it's not, 0. So x cannot equal -3. I've canceled there. So multiply across here, what do you got? The x plus 3 is canceled. They become 1, right? So multiply across, what do we get, guys? And 3 times 1 is just 3. So what's on the bottom? There you go. Golden. Okay, I want to skip B and do C. Yeah, that's cool. Actually, I want you to do C on your own.